Hello everybody, this is me and my affiliation. This is the third problem in the series of problems on mesh analysis. As you can see, in this problem typically, you are asked to find out the current through 5 ohm resistance using mesh analysis method. If the method is not mentioned, there are multiple ways of solving any given problem. And you would invariably always arrive with a unique solution. That is the best part of network analysis or analysis for that matter. It results in unique solution. Now, how to approach this problem? Unlike the other two problems, here as we can see, we can identify 3 meshes. Okay, we can easily identify 3 meshes, and if we have to solve for this network, we need to arrive at 3 equations. We have to have 3 equations because there are 3 unknowns. Typically, in order to get the desired solution, you require current I1 and I2. You need to find out the current I1 and I2. Difference in current between I1 and I2 would be the current through 5 ohm resistance. This by inspection one can always tell. Now, in this problem, this 2 ampere current source, which is between mesh 2 and mesh 3, is posing a problem. See, this mesh 1, mesh 2, mesh 3 is something that I have written. It was not given in the problem. I have written. Okay. The currents in the 3 meshes are I1, I2, I3 respectively, and correspondingly I have named those meshes as mesh 1, mesh 2, mesh 3. Okay. Even this was not mentioned in the problem. Like, I have these things were not there. This was not there. All these things were not there. I will give you the problem as it was. Like, it is like this. This was the problem that we had before us. Like this was the problem we had. Okay, we are supposed to find out the current through 5 ohm resistance. Now, how do we do this problem? Okay, so we have 3 meshes. If we independently write the 3 mesh equations, we try to write the mesh equations by inspection. This 2 ampere current source will pose a problem, which is common for mesh 2 and mesh 3. So we have to somehow find a way of arriving at 3 equations by bypassing this 2 ampere. We have to find a way out. It is something like you have a what do you say? You are going somewhere. You see on the road there is some minister coming, and obviously there is going to be a what do you say? Traffic is being blocked, and then you are in a hurry. That is causing a problem for you. So what do? You tend to take a bypass route, right? You tend to take a different route. This is just an example. So you try to avoid that particular portion of the road wherein some minister is going and there is going to be a traffic block. So similar method we need to adopt here. One can always identify that there is one mesh which is avoiding this 2 ampere current source. It does not include this 2 ampere current source. That is this mesh. This mesh. Mesh 1. We can always write an independent equation. It wouldn't involve this 2 ampere. And mesh 2 and mesh 3, if I call this mesh 2 and this as mesh 3, these 2 meshes would involve this current source as a common element. So we avoid this mesh 2, mesh 3, writing equations for mesh 2, mesh 3. So instead what we do is we try to take a loop. Yes, I suppose you know the distinction between a loop and a mesh. There is a very fine difference. Okay. Typically, a loop can be a mesh. A loop can be a mesh, but a mesh need not be a loop. This need not be a loop. Need not be. It can be, but it need not be. So how do we distinguish between a mesh and a loop? A mesh is the smallest possible closed loop in a network. This is the smallest possible. It is similar to a pane of a window. Okay? But a loop is a closed path. All right, closed path. Okay? A loop can be any closed path. This can be any closed path. Okay? This is the difference between a mesh and a loop. Though interchangeably we tend to use it because there is a very fine difference. Alright. Now, if we can choose a loop in such a manner that this 2 ampere current source can be avoided, then you will be able to comfortably write an equation without worrying too much. So, let us try to name the terminals so that it becomes comprehensible for us. So, I will name this particular point as A. All these A and B are not separate junctions, but only thing is that for better understanding I will name it like this. Okay. So, if I can identify a loop as A, B, C, D, A and write an equation, and that equation would not contain this 2 ampere current source. You are avoiding this 2 ampere current source. It is not going to interfere. Okay. So, you have one equation for mesh 1, another equation for loop ABCD, and you require one more equation. What do you do for that? The third equation now can be written for the branch current, that is the current flowing through this 3 ohm resistance, which is 2 amperes. This current is 2 amperes. We can write one more equation for 2 amperes. And you get 3 equations and 3 unknowns you can solve. Calculator will help us solve. Now, how do we do it? Okay. So, let's go ahead with the solution now. And one more interesting thing I want to mention here is this 3 ohm resistance that is there in series with a current source doesn't have much role to do. It doesn't contribute in any way. The current through this branch 3 ohms is always 2 amperes, whether it is 3 ohms in series or 10 ohms in series. A series resistance or a resistance in series with a current source can be treated as dummy. You can remove that resistance and replace it by a short. Directly you can do that, or even if it is there, it is not going to cause any problem to us. We will retain it and go ahead and see how to do the problem. Alright, now let me write the solution. Without wasting much time, we will write the solution. Okay, to make the viewers understand, I would try to take that part of the network for which we write the equation. Okay, so I will copy this portion of the network, then maybe I'll paste it here. I will adjust this. Okay, now I will use this orange color because I've been using orange color for the representation of currents. So this is my current I3, and I have another current which is flowing in this manner. This is my I2. Alright, so I have reproduced the currents for simplicity. The currents were same, but then I wanted to make it uniform. Okay, I only reproduce that portion of the network for which I am interested in writing. Now I will write an equation for this. How do I write the equation? So we will start from A and then go back. You can write by inspection or you can write by first principle. Let us try to do it by first principle so that we don't make any mistake. Okay, through 10 ohm resistance, what is the potential drop? The drop in potential is typically 10 into I1 minus I3, because I1 is flowing from A towards D and I3 is flowing upwards. So the downward current which results in the drop is I1 minus I3. Alright, now we come to 5 ohm resistance. What is the potential drop? Plus 5 into, it is carrying a current of I1 in the downward direction and I2 in the upward direction. So the difference in current is going to be I1 minus I2 from top to bottom, which is taken as a potential drop. This is equal to the gain in potential and 60 volts. We are going in clockwise direction. typically we go in clockwise direction. Our route is normally from top left corner in the clockwise direction back to top left corner whenever we write a mesh equation. This is my equation 1. I suppose it is simple and clear. Alright. Now, we will now take the other portion of the network for which we need to write the equation. I will now pick this part of the network. This part of the network, because I would be writing this. Okay. But then here I need to get rid of the unwanted elements. I'm not taking care of this. This branch I'm not now including in my equation. Okay. Now I am doing this portion I am taking up. And what is the value of this resistance? This resistance typically has 10 ohms, right? This is 10 ohms. This is 10 ohms. Now I write another equation. Alright. I suppose it's very clear. We will write the equation. I'll take back my white pencil, then I'll do. Okay. I'll go from top left corner. That is, I'll start from A, go to B, B to C, C to D, D to A. That is my route. That's how I do. Okay. So it's 2 into, what is the potential drop? 2 into I3. It's carrying only I3 amperes of current. Then I come to 1 ampere, 1 ohm. This is 1 into I2, which is a drop in potential. Then I go to 5 ohm resistance. Okay. I need to put this current also. I'll use the same pencil. It shouldn't matter greatly. This is I1. Okay. Now plus 5 into, what is the drop in potential? Drop in potential is 5 into I2 minus I1. Then plus 10 into I3 minus I1 equal to 0. Alright. This is the equation that we have. Okay. So it is very, very simple. There is nothing complicated about it. It is very simple. Plus 10 into, I will write it here only, equal to 0. Let it look little elegant. Alright. This is my equation 2. Alright. Simple enough, clear enough. Now what is the third equation? You require one more equation, right? There are what do you say, 3 unknowns, so you require 3 equations. So what is that portion of the network which we would be requiring? So I will take this portion of the network which I would require to write another equation. Dear. What happened? Sometimes these gadgets, they pose some problem. I will erase this. I'll take this figure onto one side. Okay. So I have taken this one. I will now put the currents. Okay. This is my I3 is flowing like this. And my I2 is flowing like this. Okay. Now I'll write one more equation. If you look at this 2 ampere is going from right to left. Okay. So I have to write an equation for this 2 ampere. That is the current in this branch, which is the difference between the loop currents. Okay. So I'll be justified in writing I3 minus I2 equal to 2. I3 is from right to left, I2 is from left to right, and as 2 ampere is from right to left, so I3 minus I2 equal to 2. Alright, this is my third equation. Now 3 equations are there, 3 equations and 3 unknowns, so you will be able to solve. Okay, so I will rearrange these equations for our simplicity. Okay, I will expand these equations, 1 to 3 equations, and then write it. Okay, so I will do this work here itself first. This is 10I1 minus 10i3, I'm opening up the brackets, plus 5i1 minus 5i2 equal to 60. Okay, that will be 15i1 minus 5i2 minus 10i3 equal to 60. There are two i1s which are added up. Okay, this is my equation, let us say 4. I've called this 4. Okay, and I'll pick this equation 4 and I'll paste it at the bottom so that I will be able to use it methodically. Now I will have to adjust with the second. I'll have to do the second equation. I'll expand and group the terms. 2i3 plus i2 plus 5i2 minus 5i1 plus 10i3 minus 10i1 equal to 0. So how many i1s? Minus 15 i1s. It is preferable to group in this order only. i1, i2, i3. Okay, how many i2s are there? 5 and 1, that is 6 i2. Okay, and then how many i3s? 2, then 10, that is 12 i3 equal to 0. This is my equation 5. I'll pick this equation also. I'll copy this equation, put it underneath this so that they come one below the other. And equation 3 can now I will write it as equation 3. I will write it as minus i2. See, I am writing minus i2 first, then i3 equal to 2. So that while feeding in the calculator, I won't do any mistake. Even I can write this as 0 i1. Okay. Now you feed these values in the calculator and you will get the solution. Solving for i1, i2 and i3 from equations 4, 5 and 6, we get, you can even feed this, and if you do this, you will get i1 equal to 24 ampere, i2 equal to 18.66 ampere and i3 equal to 20.66 ampere, and that would complete the problem. As you can see, here i3 minus i2 is 2 ampere. Okay, that is the result. But then this is not the end of the problem. We are supposed to find the current through 5 ohm resistance. Okay, so what is that 5 ohm resistance? 5 ohm resistance will be carrying a current of i1 minus i2, because i1 is greater, i2 is lesser. So we will find out I through 5 ohms. Rather, I would write it properly. I mean in the sentence form. Current through 5 ohm resistance is equal to, how much is that? Maybe I require a calculator. Typically, like, like most engineering students do, they tend to, use a calculator even for simple computation. This comes out to be 5.34 amperes. 5.34 amperes. Okay, this is the magnitude of current, and the current is flowing from top to bottom. Okay, so that completes the problem. Okay, I will enclose this also in a box. Oops, I will be a little slower, then maybe it will take now. Oops. Okay, done. Okay, that completes the problem. Okay, 5.34 amperes is flowing through this 5 ohm resistance. Like, it is like this. This is 5.34 amperes. That completes the problem. You're supposed to do it this way. So as a summary, as a technique, I would like to mention that you try to pick a super mesh. Sometimes in certain books, this ABCD is referred to as a super mesh. So you try to avoid, you try to bypass the current source, which is common for both meshes. Try to choose a super mesh and write an equation, and then make use of the branch through which you have the current source and write another equation, and the problem becomes simple and usual. Alright, I suppose this video helps you in understanding problems of this nature. See you in the next video. Thank you.